Okay, hello guys. So now let's take a look at a geometry sample problem in AMC 10. So in this problem here, we first know that we cut off the largest semicircle in a right triangle ABC. Okay, so this triangle here is a right triangle. And then we know that the diameter of the semicircle is on the hypotenuse AB, and given that the length of AC is equal to 210 centimeters. So we can say it's 210, and also we know BC, the other leg, will be 280. Okay, so we want to find out the total area of the shaded region in this figure. Okay, so of course we cannot really find this this part of the shaded regions at this point here, because you can see those are irregular shapes. But instead, we can try to use the area of the triangle ABC and subtract the area of the semicircle. If we can do this, then of course we can find the area of the shaded region, right? So can we find the area of the right triangle? Well, I mean, we know the two legs of this right triangle, so of course this one is clear. So we do have a way to find this area. But what about the semicircle? So for this semicircle, if you want to find out the area, you first need to find the radius. But the problem is we are not given the radius of this semicircle, which means we now have to first find the radius. Okay, so let's see how we can find this. So first of all, how can we find the radius? Suppose we have just the center of the circle at this point here. Okay, let's say here we have the point O. Then of course the distance from the point O to say the point D here will be the radius, and same as from the point O to the point E, right? But again, we have no idea about the length of DE, so we cannot really find the radius from these two sides. Okay, but what if, since we are trying to find the largest semicircle from this hypotenuse, right? So we know this circle has to be tangent to the two legs. Because think about this, if you have a smaller circle, then of course it's not really tangent to any legs, right? So the idea is that if we can also find the tangent point, if we connect the tangent point to this center, we can see that this part here should also be the radius, right? And also if you connect from the radius to this tangent point, it will also be the radius, okay? And also we have one theorem about this tangent about a circle, is that if you connect the radius from the center to the tangent point, then this radius is gonna be perpendicular to this tangent, okay? So in this case, we first know that we have a right triangle here. And let's call this point to be our point F, okay? All right, so once we connect these points, and of course you don't have to connect all the radius, but first we notice that the triangle BFO is actually similar to the triangle BCA. Right? And how do we know this? Well, first of all, they both have this common angle, right? So we can prove this using this angle B. So we know angle B equals the angle B. And also we have this two right triangles, which are the angle BFO equals the angle C. So because of these two congruent angles, we can conclude that the two triangles are also similar triangles. And what do we know about the similar triangles? Is that if the two triangles are similar to each other, then we know the corresponding sides are also in proportion, right? So in this case, we know BF, which is the leg in the triangle BFO, to the corresponding leg, which will be the BC, is now equal to FO over the CA. Okay, and we can actually represent this sides using either like a number or use the radius. So for example, the BF could be represented as a 280 minus the radius. And for the BC, it's just given as a 280. Okay, and FO, it would just be the radius itself. So we have the R, and also for the CA, we have a 210. Okay. All right, so once we have this, like the equation, we can just solve for the radius. So what we can get is that 280 minus the R. So or let's just try to open this parenthesis. So we multiply this by a 210, and then minus a 210 and R equals a 280. R. Okay, so we can use the cross multiplication, and then we can just combine this R's and also simplify this calculation. So we have the R equals 280 multiplied by 210 divided by a 280 plus the 210. So it would be a 490. Okay. So first thing you might notice that if you want to simplify this calculation, you can just get rid of the 70 from the top and the bottom here. So you can get a 3 and you can get a 7, and you can also simplify this into a 40. So you can get the radius to be 120. Okay. All right. So now let's keep going. So we know the radius of the semicircle. So of course the area of the semicircle, let's just use the area semi here, equals 1/2 multiplied by pi times the r squared, right? Because we know pi r squared will give us the area of a full circle. Okay, and just plugging everything we know, we want to let the pi equals 3. So we have 1/2 multiplied by 3 and multiplied by the radius is 120 squared. Okay, and then let's just try to also try to simplify this, and this will give us a 120 here. Let's just leave the answer as this because we want to simplify this later. Okay, so now let's just get back. So what about the area of the triangle ABC? Well, this will just be 1/2 multiplied by 280 multiplied by 210. Okay, so if we put them together, then the area of the shaded region is now equal to the area of the triangle ABC. So 1/2 multiplied by 280 multiplied by 210, and minus the 3/2 multiplied by 120 to the second power. Okay, so we can just try to factor out a 1/2. So in the parentheses, we just have a 280 multiplied by 210 and minus a 3 multiplied by 120 to the second power. Okay, so simplifying this calculation, we can get, let's see here. So if we do a 280 multiplied by 210, this will give us a 550,000 or something here. And also we have the power right here. So we should have a 1/2 multiplied by 15 and 600. Okay. And then we just divide this by 2. So we can get a 7,800. Okay. All right. And if we go to the choices, this will be the choice E. All right. Okay. So in this problem here, we just use this similar triangles and try to find out the radius of the semicircle. And again, you just want to follow on this problem here to see what is the information that you still need, and just try to find them and solve the problem.